So what is a circular polarizer filter? I explained polarizer filters in another video, and I have to admit, after watching it again, it's not very good. The audio is not very good and all that stuff. But I do explain what a circular polarizer is. In that one, I go into a little bit more detail about how to use polarizing filters and why they're beneficial and all that. In this video, I'm going to kind of cut out all that stuff, and I'm just going to talk a little bit about what polarizing filters are, so that it makes sense when I explain what a circular polarizer is. And then I'm going to explain what a circular polarizer is. So getting into it, let's first talk about what is a polarizing filter. If you imagine a polarizing filter is like a series of parallel lines that are black, and basically light is a particle and a wave. So it's like imagine a particle like doing this. Now the interesting thing about it is that it can't fit through a hole that's just particle sized. The whole wave has to be able to fit through. So the interesting thing about the polarizing filter is that when you have these parallel lines, a light wave can go through this way, but it can't go through perpendicular to these lines or at certain angles. So what happens is when light passes through a polarizing filter, it becomes polarized. All the light is in the same orientation. The nice thing is it allows you to selectively remove light or allow light through depending on the application. Now another interesting thing about polarizing filters is if you have one that's set up this way and then one that's set up this way, it actually will block all light because there's no orientation of light that'll get through two polarizing filters perpendicular to each other. Another thing that's interesting about polarizing filters is that they actually can spin. So when you screw it on, the outside ring allows you to spin the filter, and that allows you to basically adjust what orientation those lines are so that you can select different polarities of light. Circular polarizing filters were developed probably, I think it was like the 80s, 90s-ish, and basically what happened was that camera manufacturers were starting to introduce things like autofocus, program mode and all that stuff with auto light meters. And the way they were doing that is they were sampling some of the light that was coming through the lens, and they were redirecting it down into either the autofocus sensor or into the light meter. And they're using polarized light to do that. Now the problem is, like I explained earlier, if you get two polarizing filters that are perpendicular to each other, it cancels out the light. No light gets through. So all of a sudden, if you're using a polarizing filter and you have it on the exact right setting, the camera can't see. All of a sudden the light meter sees zero light and the autofocus doesn't work. And so to eliminate that, what they developed was what they call the circular polarizer. Now some people think that it's circular, so it means like instead of having parallel lines like this, you have circularly parallel lines, and that's not the case. And the reason being is that you wouldn't really be able to select anything with like you'd still have light coming in at different orientations at different parts of the filter, and so it just wouldn't work. But what it is instead is that it's like a two-piece filter. So on one side you have the polarizing portion. On the other side they have what they call a randomizer. So the light comes in, it gets polarized as it's going through the polarized portion of the filter, but then it goes through the randomizer, which basically depolarizes the light. So now when the camera is sampling polarized light for the light meter or for the autofocus, you don't have the issue of it canceling it out where it doesn't see any light at all. So I can actually demonstrate that. This one is just a regular polarizing filter, and then this one is my circular polarizing. Yep. And the difference is it says like CIR for circular polarizer, and this one just says polarizer. So what you're going to have is so this is the side that screws into the lens, and this is the side that would face out to the world. The polarizing filter would be on this side, and the randomizer is going to be on this side. So now if I hold these things up so that the circular polarizer, it's facing towards me, and the randomizer is this way, if I spin it, it doesn't ever cancel out. Like I can always kind of see the camera. Yeah, it's a little darker because you're going to lose some light. But now if I flip it around so that the two polarizing are facing each other, so now the randomizer is here. Now I do it, it goes black. Do you see that? Like here, you can see, and then there's black. See? Black. See? black. Okay, I realize that it's difficult to see the way I had it set up, so now you can see the two filters. This is just the regular polarizer, and then this one's circular polarizer. Now, what I'm going to do, as long as the two polarizing sides, so this is the side that faces away from the camera, this is the part that screws onto the lens, this is where the randomizer is. So as long as the two polarizing filters are facing each other, they'll cancel each other out. You can see how it goes dark, it's visible. Now if I flip, this is the circular polarizing filter. If I flip it around so the randomizer is between the two polarizing filters, you can see there's no change. Now you can see some weird color changes that occur. That's probably a combination of just the quality of the filters and you know, going through a randomizer, but it doesn't black it out. Now, so here's the circular polarizer again. If I face the randomizer away and the polarizing filters on this side, here's the linear polarizer. So again, they'll start canceling each other out. This one I can flip around and they still cancel each other out. So you can see that this is the linear polarizing filter right here. It doesn't matter the orientation. However, if I do it with the circular polarizing filter, cancels each other out, flip it around, now it doesn't. See? Flip it back, boom, boom. Fun times. Fun with polarizing filters. Who knew it could be so much fun? So that's pretty much what a circular polarizer is. Nothing very complicated. Some people do say that the circular polarizers are not going to be as good as like a regular polarizer, and that's one of the reasons why I bought one of these. If you're not using autofocus or the light meter, then you can use a linear polarizer just fine. If your light meter suddenly goes wacko, the nice thing with digital cameras, you can take a picture and see, like, if everything's all funky, then you know something's wrong. And you can shoot in manual mode. But a lot of people do use the autofocus function and like to use the auto and like to use like program mode or something like that. So that's where the circular polarizer becomes in handy. Now, just a little side note, polarizing filter is something I would suggest you buy. It's not something you really Photoshop in later. It's the effect is kind of, yeah, can't be Photoshopped basically. You basically can remove glare, you can darken the sky and all that stuff, all these neat things that the darkening the sky you can do in Photoshop, but removing glare and such you really can't do. The other nice thing is if you're trying to do long exposure stuff, circular polarizer filter acts kind of like a neutral density filter, so it darkens things, so it increases your shutter speed, which is great if you're trying to do like kind of, like I said, longer exposure landscape stuff. And then the other weird just thing to note, you know, like I said, there's usually a little notch, or this one has a little circle that symbolizes like the orientation of the filter so that you just know what it is. And then this one here has a little white dash, which you may not be able to see from that direction, but it'd be interesting to see. So here they are lined up together, the dash and the circle. And then if I put them 90 degrees to each other, it goes opaque. So that's, you know, kind of an interesting thing. So I guess you could tell then, or nearly opaque. There you go. This is also just kind of a side note. If you ever see any pictures of nuclear bomb explosions where they're frozen in mid-explosion, it's actually using a system of two polarizing filters and then a medium in between that randomizes the light and allows it to pass through. And they're able to control the shutter speed very precisely. So I hope you liked the video. If you did, please give it a thumbs up. Consider subscribing. I do kind of a mishmash of things, including photography, car stuff, farm stuff, whatever random stuff. I'll be doing a few more astronomy stuff coming up this summer, I hope, so you can look forward to a few more videos. If you have any questions or comments, constructive criticism, please leave it in the comment section. If you have, especially questions, if you want to see a particular video about something you know, that you've always had a question about, feel free to leave it in the comment section, and Maybe I'll try to get to it one of these times. Again, thank you, and take care.